Quantum computing is here, and the race to harness it is reshaping the global technology order. Unlike classical computers, quantum machines can process certain problems exponentially faster. The implications are spread across drug discovery, financial modeling, cryptography, and energy optimization. Just think of a maze to be maneuvered. A classical computer will run a solution, fail, and then start over. But quantum computing is like a mist descending on a maze. It runs several solutions together, making it an extremely fast system, but with complicated circuitry which needs to be maintained at a particular temperature. India today is among a select group of nations with a dedicated national quantum mission with an allocation of approximately 6,000 crore rupees spanning 43 institutions across 17 states. And on World Quantum Day on April 14th, India took a giant leap. It unveiled the world's first open access, made in India quantum computing ecosystem at Amaravati, a greenfield city on the banks of Krishna River. In this episode, we ask, what is actually being built at Amaravati Quantum Valley? Who is it for? What real-world problems can it solve? It is Thursday, the 16th of April. I'm your host, Nidhi Sharma. You're listening to The Morning Brief. So, what is making India's quantum computing story genuinely different? The center of this ambition isn't Bangalore or Hyderabad or Mumbai. It is Amaravati, a city still largely under construction, where quantum is being built in as a foundational economic pillar rather than an add-on to an existing tech cluster. That a planned capital city in Andhra Pradesh is emerging as India's quantum nerve center tells us something deeper about how the next technology is being seeded in new, smaller cities, not inherited by old ones. On April 14th, Andhra Pradesh Chief Minister N. Chandrababu Naidu unveiled two quantum computing testing beds, one S and one Q. One can say that India's best scientific minds have come together to collaborate and make this possible. Now, Indian researchers and startups can test their components to check efficacy and build more powerful quantum computers. We first turn to the man overseeing the technical architecture of what's being built here, CV Sridhar, Mission Director of Andhra Pradesh State Quantum Mission. Thank you for joining us today, Mr. Sridhar. Please do tell us about the initiatives that are being taken in Amaravati Quantum Valley and how is one S and how is one Q so different from what India has done so far?
Yes. So what we had launched at Amaravati Quantum Valley is a hardware reference facility. So we've launched two such reference facilities, 1Q and 1S. So these reference facilities will give some of the foundational capabilities required for building the hardware component manufacturing ecosystem. To test any component that we are building for a quantum computer, we need a reference facility to test those components. And this facility is not there. And our researchers typically go to countries like Netherlands, US, Germany to get this testing done. And it is a very expensive process. So this will help India to build better quantum computers and more powerful quantum computers, and also triggers the local component manufacturing ecosystem.
Sir, are you also, telling other state governments to work with you and have certain, problem solutions that they must be grappling with?
So what we are doing is trying to identify use cases. So we have set a goal of 100 quantum algorithms by 2028. So our goal is to identify the problems that are suitable to be solved on quantum computers. Today, what we have is a very small quantum computer that is available. IBM's 133 qubit quantum computer that is coming into Amaravati Quantum Valley will help us to reimagine some of these problem statements. So these problem statements are coming from different industry sources and governments. So one such example is the optimization of location of ambulances. So the state government has provided us the data about the positioning information, call information, doctors information, patients information, and we combine all these things to build a optimization problem for identifying where do we put ambulances at right locations. So we try to fix the route, or we try to put the ambulance at a particular place, assuming that that is an optimized version. And then we have the call information based on the historic data. Again, we build patterns around that one. So we do that in layer by layer. And what quantum gives us an opportunity to do that is all at once. We were also given another problem statement about network optimization. So most of the state governments have got this project called BharatNet broadband. So it is important to position the network elements right so that we get optimum bandwidth and the bandwidth distribution to different locations. So this is another use case that we got from the state government. So this can be solved using quantum computing. Another example of this one is the price optimization for the power scenario. So today, typically because of the PM Suryagar project, we have consumers who are also producing electricity and putting that back on the grid. And apart from that, we have multimodal projects that are going on, right from power coming from different sources like thermal, power, pump storage schemes, solar, and many other sources. Again, creating and modeling this problem for building an optimized grid is an extremely complex problem. And we need to continuously reduce the power price in this whole process while making new investments. So we try to use quantum computer, model it, simulate the duck curves, which because the weather patterns will determine how much electricity we produce on a daily basis, and that again in turn is put back onto the grid. So these are problems that we are receiving from different industries and governments. The problem today is the quantum computer that is available to us is has got fewer number of qubits. So we have 133 qubits state of the art machine. But to solve complex problems like this, we need about 1,000 qubits. And that is the time and when we reach return on investment kind of scenario for these investments. The other challenge we also see is as quantum computers get better and better, so we also need to continuously upgrade our skills. So we are having challenges that we need to continuously upgrade ourselves to solve this problem. And once we get a 1,000 qubit kind of scenario, that's when we will be able to solve bigger problems like this.
What is so unique about what we have at Amravati? Like you said, it's an open access. So when we say open access, just deconstruct for us what does that mean and what are the researchers doing right now?
Typically, quantum computers are restricted technology, so no company will allow any scientist to get closer to the quantum computer. This makes it extremely difficult to understand the internals of the hardware. So this is for a school student or a engineering graduate who is trying to understand. And what this open access system will enable students is they can go see this machine, understand each of the parts of this quantum computer. So there are multiple things that needs to be deconstructed to build a better quantum computer. And that facility is not available for us, which means we'll not be able to build a quantum computer. So what this open access quantum computer is providing us that ability to characterize each and every component that goes into the machine. And then together we can build better machines.
Sir, what is the problem this is solving for startups in this field?
So most of the startups are doing in isolation within their labs using the instrumentation that is available to us. But that does not give the real world capability of checking whether the component is working in a real world environment. So they again send this component to say the Delft ecosystem, so where they will get access to such test bed, just like the reference facility. So they will get access to one such test bed, which will cost them huge amount of money. So by putting this in India, so now they can send the component here and then do this repeated experimentation. So it will significantly reduce the cost and time also.
Sir, could you tell us what was the timeline like? How did you begin with Amravati Quantum Valley? What was the mission statement? Could you tell us your journey to which
Yeah.
fructified into one S and one Q, sir?
Amravati Quantum Valley project was started in last May when Honorable Prime Minister made an announcement about the AQV. So this started with the announcement of setting up IBM and TCS quantum computer into the Quantum Valley. And since then, the Honorable Chief Minister has roped in all the national experts of the country, and ask them to create a vision and mission document. So the vision is to be among one of the top 5 global hubs. And we have a mission statement that has come out in the form of Amaravati Quantum Valley Declaration, a series of items that were given by these national experts. The mission is now organized under 5 pillars. The first pillar is on building this infrastructure. The second pillar is hardware. Then the third pillar is research and innovation around algorithms and software capability. Here we are taking multiple tracks here. So one is on the quantum biofoundry initiative, where we'll be working on use cases for drug discovery and healthcare. The second one is the banking and financial services cluster, where we're working on open innovation concepts for post-quantum cryptography and algorithms that are useful for banking and financial services. The third initiative is the Quantum Incubation Center. So the fourth pillar is partnerships, and the last pillar is talent. So which is important to support all these 4 pillars. This is the state where we have a special scenario. People join engineering and then migrate to different places. Now our opportunity or our challenge is to bring them back into the city and make them work in Quantum Valley. So that's a goal that we have set. So we're training them. So after the foundation level, so we will take them to advanced level and the elite level. And goal is to create 3,000 experts in the next 2 years. One good thing that is happening here is most of the research institutions of the country, like the CSIR, DRDO, CDAC, CDOT, and the DAE. So all of them have expressed interest to be part of Amaravati Quantum Valley. So we have 4 hubs from DST. The 4 hubs are working on 17 different projects, which are working on the mission, objective statements of the National Quantum Mission. So good amount of outcomes are coming from there. And we now are creating an ecosystem that translates these outcomes into innovation. So the goal is in the next 2-3 years, we focus on the technologies like quantum, AI, semiconductor, cyber physical systems, and communication technologies. All together will move forward and then create a nice ecosystem around here. So that will help us to achieve our vision statement.
Mr. Sridhar just told us that Indian researchers and startups routinely ship their components to the Netherlands, the US, and Germany just to get them tested at an enormous cost and time delay. So, who's building the infrastructure to end that dependence? Companies like Qubitech. Our next guest is its founder, Prudhvi Pinnaka. Hi, Prithvi.
Hi, Nidhi. Thank you so much for having me.
So, Prithvi, please tell us, how did you get involved with this project, and what is your company all about? How has it got involved in the entire Quantum Valley project?
Yeah, so what exactly we are trying to do is that for any industry to start off, it needs to have a strong infrastructure, which I mean is the supply chain. So I come from a supply chain background. So I am an IT Bombay graduate with a MBA from IIM Bangalore. So I worked predominantly in BCG. So the main objective for us was to develop the infrastructure that is required for this mission to succeed. So we've set up the first facility, but we hope to see more than 50 such test facilities over the next 2-3 years and reach 100 by the end of the mission. The reason is that Netherlands has close to about 65 or 70 test beds spanning across different technologies, superconducting, neutral atom, photonics, almost every technology that is there in the quantum space. So our objective is to use those facilities to test products, accelerate the research, and last and most importantly, give hardware access to the research facility and the faculty over here.
So, Prithvi, tell us about Qubitech and what does it do?
So we have started in 2025 December. Coming specifically to the Amaravati Quantum Valley, we have 2 MOAs with the government. One on the skilling, where we have enrolled almost more than 64,000 students as part of the Visor training program. And the second MOA is the one which we are currently working on, is to set up reference facility and thereby attract startups, investors, and researchers to this particular facility to utilize this facility to run their test bed and characterization. And as part of that, we have signed an MOU with the Andhra Pradesh Quantum Valley. We are going to make close to an investment about 2 million in this particular year. The system is already invested, and the next investment is going to be on the. We want to do a little bit of backward integration as well. Lastly, if I put it simply, right now we don't have any standards. There are no Indian standards in quantum specifically. So we want to be that particular node to develop standards in by working closely with the National Quantum Mission and National Physical Laboratory to set up those standards, and which are of course in sync with the global standards and characterize components based on that, so that these things can actually be sold in the real market and the startups can become big.
Are you being flooded with queries and requests for testing products?
Yes, we did get good requests. I mean, right from in the startups which are faced in the AQA building itself, they have approached us. We also want to do effective marketing so that we reach out to all the key important players in India. And not only in India, there is also a demand in Singapore, Dubai. So we also want to target that in the next phase.
And how do you scale up this?
So as I said, right, the target we set out to ourselves is over the next 3 years, we want to set up 50 such facilities. So there are a lot of partner academic institutions which are keen to set up such facilities. So we have signed an MOU with Chandigarh University. So they are interested in setting up such a facility. So similarly, there have been requests from Mumbai as well, another university. Hopefully, even industry comes into this, right? The best way that can happen is, as I said, like institutes like these and other industries come and invest in this particular ecosystem. And gradually, as we grow, we would also want to open multiple such systems here itself in Amaravati.
From ambulance routing to power grid optimization, the use cases are real and the infrastructure is finally catching up. Amaravati may be a city still finding its skyline, but in quantum computing, it's already staking a claim on the future. That's it for today. This episode was produced by Anirban Chaudhary and sound designed by Rajas Nayak. Keep listening to The Morning Brief wherever you get your podcasts. This is your host, Nidhi Sharma, signing off. Have a good rest of the week.